Our I can for today is E3. I can solve one-step multiplication equations. Before we begin, I want you to take a look at the video. The link is listed here on the slide. I want you to watch this video. It's about 15 minutes total, and it's about equations and balancing on the scale. And I think that it will really take what we've learned in the two previous lessons and really help you to make sense of why we do what we do. There are questions that go along with the video that you can answer on the handout. All right, so building off of what we saw last time and what we just saw in the video, we have the equation 2x equals 6. Now remember, that means that we have two x's. So I have two of those x pawns on my balance scale, and I have positive 6 on the other side of my scale. Now this is a little different because I have two x's. So it's not another number that's on the same side of the scale as x. I have two x's. So what I need to do is figure out a way to tell what 1x equals. Well, what I can do is I can take the two sides of my equation and I can divide them both into two equal groups. So I'm going to take everything that's on the left side and split it evenly into two different groups. And then I'm going to take everything on the right side and split it evenly into two groups. So notice my two x's are split into two groups with one x in each. My 6 is split into two groups with 3 in each. Now, what this means is one group from the left side has to equal one group from the right side. So what that means is 1x has to equal 3. Now let's take a look at how we would show the same steps using evidence with our abstract or algebraic representation. So I'm going to draw a line down the center to keep my two sides separate. Now I have two groups of x, so I want to divide both sides by 2. You can show that either using our old-fashioned division symbol, or you can show that with a line underneath. It's like you're making it a fraction, dividing it by 2. So those are two different ways that we can show it. This second way is the most traditional, but either way is acceptable for evidence. So 2 divided by 2 becomes 1, so I have 1x. Okay? And 6 divided by 2 equals 3. So 1x equals 3. Now remember, if we just have 1x, we can also just write it as x by itself. So our final answer is x equals 3. Let's do the check. Remember, for the check, everywhere we see an x in our original equation, we're going to plug in a 3 instead. So 2 times 3 should equal 6. And indeed, both sides equal 6, so I know that I have the right answer. So, what's the rule? If x is multiplied by a number, divide both sides by that number. Okay? And remember that the number in front of x, the number that x is multiplied by, is also called a coefficient. So another way of writing this rule is divide both sides by the coefficient of x. Okay, let's take a look at another example. Now this time, n is divided by 2. Remember that that fraction bar is another way of saying divided by. So n is divided by 2. So remember how if n was multiplied by a number, we needed to divide into groups to get x by itself? Well, in this case, if we have one n that's divided into two groups, just like we saw in that previous video, we're going to multiply both sides by 2. Okay? Now, let's talk about what's happening here. So if I have n over 2, or n divided by 2, and then I'm going to multiply this by 2, well, that's like multiplying by 2 over 1. And when we multiply fractions, we know we can cross-cancel. So 2 divided by 2 is 1. 2 divided by 2 is 1. So I end up with 1n over 1, which is simplified as n. So remember that if n is divided by a number, and then you multiply that number, the effect is you cancel out both of the 2's because they both just end up with a factor of 1. So on the left side, we have n by itself. -4 times +2 is -8. Let's test our answer. So we're going to plug in -8 in our original equation. So I'm going to write -8 divided by 2, and I want to see, does that equal -4? Well, I know the right-hand side is -4, so I'm going to type into my calculator, -8 divided by 2, and indeed, I do get -4. Since these are both the same number, I know that n equals -8 is my final answer. So, what's the rule? Well, if n is divided by a number, then we want to multiply by that number. And remember that we want to do this to both sides so that we keep our equation balanced. Now, let's take a look at this problem. So remember, you can always draw a line down even if you're not sure what to do of next. I want you to find A, and I want you to determine, is it multiplied or divided by a number? Now this one's kind of tricky because it has a fraction, and so we might be thinking, oh, well, there's that division bar, but the division bar isn't under A. Okay, so this is not the same as our previous example where there was A divided by a number with a number on the bottom. So this is actually a multiplication problem. We have -3/5, that's a number, times A. So what do we do if we have a multiplication problem? We want to divide by the number in front. So I'm going to write divide by -3/5, and I'm going to do this on both sides. Okay? Now, any number divided by itself is 1. So -3/5 divided by -3/5 equals 1. So I have 1A now. These have canceled out. So I have A equals on this side. Then I can type into my calculator 2 divided by -3 ABC5. So notice in between these two, I want to use the division button. Okay? But then it's fine if I use the ABC button on the fraction. Okay? I get -3 1/3. Let's do the check. So I am going to plug in for A my answer. So I'm going to write -3/5 times -3 1/3. And I want to see, does all that stuff equal 2? Well, I know what one side equals. That's 2. I'm going to type into my calculator. -3 ABC5 multiplied by, make sure that's multiplication, multiplied by -3 ABC1, ABC3, and indeed we do get 2. So we know that this is our final answer. Now, a quick note at another way you might see this problem solved. So, we know when we're dividing fractions, we use copy dot flip, right? So if we're going to compute this division up here, we would copy the first fraction, -3/5, then we'd change the operation of multiplication, and then we'd flip the second fraction. So we would write negative 5 over 3. Now, before we multiply, we know we can do some cross-canceling. So we can divide 5 out of these two to get a factor of 1. We can divide 3 out of these two to get a factor of 1. And the negative times a negative is going to end up with a positive. So we end up with positive 1, which was what we wanted, 1a. But I point this out to show that sometimes when showing evidence, when we're dividing by a fraction, you will see people instead multiply by the reciprocal. That's this flipped fraction. So know that it would be just as valid for your second line of evidence, instead of showing divided by negative 3/5, to show multiplied by negative 5/3. Either way works. All right, let's take a look at another form of rational numbers, decimals. We have 1.5 times q, so we want to divide both sides by 1.5. Okay, now remember, this is our traditional way of showing division. You could also show division this way. So divide by 1.5, divide by 1.5. So 1.5 divided by 1.5 is 1. So we have 1q. And then I'm going to type into my calculator, negative 8.4 divided by 1.5. And I get negative 5.6. So let's do the check. I'm going to plug negative 5.6 in for q. So I get 1.5 times negative 5.6. And I want to see, does that equal negative 8.4? I type into my calculator 1.5 times negative 5.6, and indeed I do get negative 8.4. So since both sides of my equation balance out, I know that this is my final answer. Q equals negative 5.6. Hopefully this has helped you understand one-step equations where there's multiplication or division with the x or our variable. And remember, you can watch it as many times as you need to. You can pause before I go through the explanations so you can try them on your own. Thanks for watching.